Hi there. I'm here today to talk about and demonstrate my wireless fog machine controller here that I had made. So, kind of the reason that I made this was because this fog machine here that I've had for a number of years um, originally came with this wired controller. See, it just uses a IEC 320 C13 connector on it, which then C14 connector, which plugs into the back there to control the fog machine. But as you see, a major inconvenience of it is that it's not wireless, and so you can only be as far away from this fog machine as this cord is long. Of course, you could use extension cords and stuff too, but again, wireless is just more convenient. So So as I stated, I'm here to explain this how this controller works, as well as the history of this little project of mine. But before I get into explaining that, I'm just going to talk about how this fog machine works here. So here's the fog machine with the cover removed. So there's not a whole lot going on here. There's no digital components in here. It's just all analog stuff going on. So the main kind of point thing into this is you got this 400 watt heater in here. And you see I have this little this pipe clamp going around it, and that's because when I was servicing this and just doing some cleaning on it, the little Foley flaps on this broke, so I had to figure out a way to get to keep this on here. So just this pipe clamp works, and I mean it hasn't caused any trouble, so I think I'll just leave it there. Then of course you got the little pump here. It's always worked very reliably ever since I had the fog machine. Around back here you got the main interface connector here, fuse, illuminated switch to tell you that the fog machine is running. Of course, you got the tank here, and the tank also contains, as you can see, the yellow wire there, some float switch, which keeps the pump from pumping if there's not enough fluid in there. Down below the heater there, kind of attached to it is a thermal fuse that disconnects power from the heater and the controller if if the thermostat breaks and the heater starts getting too hot. And then finally, the main star of the show here is this KSD301 bimetallic thermostat, which controls the whole show, which I'll explain here just shortly. I know when I was building this third version of the controller, I also did a little bit of a rewiring in here because it needed it. But then also this thermostat, the original thermostat in here was not reading reliably anymore. It was whenever I put my multimeter on, it would read between half an ohm and like a few hundred ohms. So I figured it was done. So I tracked down a replacement for this, and this fog machine works very well now. So how does this fog machine actually work? So we'll just go to the actual schematic for it. So as you see, it's a fairly simple device. So when you first turn the power on, obviously the neon bulb turns on, then all the power immediately goes to this thermal fuse. So that cuts power to the heater, and thermal switch, and the remote if the heater gets too hot. So heater heats up and it gets to about 240 degrees Celsius. Thermal switch senses that, and then it'll open when this reaches 240 degrees C. So what happens is, during normal operation, this acts as basically a short across the remote to keep it, to keep the remote basically turned off, and you can't use the pump obviously, because when this is a short, basically there's zero voltage between the green and the black, and then of course the white as well, and then of course between the green and the white as well for the pump, so the pump can't go. So when this opens, this forces power current to go through both the heater and the remote, or of course in the standby notification mode, just the neon bulb. So The neon bulb is a very high impedance of about 56 kiloohms compared to the 38 ohms of the heater. And so what that does is that effectively turns the heater off because almost all the voltage gets dropped across the neon bulb and any series resistor you have with the neon bulb. Basically the only thing that keeps the heater, up to temperature when the thermal switch is open is just the bit of insulation packed around the heater there. So, as I said, when the thing gets up to temperature, this opens, and so voltage appears on the green, or on the common live, I should say. So that turns the neon bulb on to tell a user fog machine is ready. And so then the user can press the switch, or an automated switch can go, and that connects live to your pump. I forgot to put in the schematic here that between the pump and the remote, there is this little float switch there, just to make sure that the pump doesn't go if there's not enough fluid in the fog machine. So that's how that works. So as you can kind of guess from this, a little bit of a sketchy thing that the designers did here with their choice for the fog machine. So they used for the control interface a IEC 320 type connector. So on the case on the box of fog machine, it's the C13 variant because it has the female holes there. And then as you can see, the normally considered earth pin is common live. The black or normally live wire is used as a neutral for the neon bulb, and then the white wire connects after the switch to the pump to provide live to the pump. So that's kind of with a design choice with the fog machine that these designers made. But I'll explain here in a bit why it's not too much of a problem if I'm using my wireless controller. The main issue that comes up is, so first of all, the remote, it's made entirely out of plastic, so you can't get a shock off of it. So that's not the problem. But say, for example, you want this remote to be longer. Well, you have to plug extension cords into the back of this. And that means, specifically, a C13 end will be sitting out there flapping in the breeze, and if you have this at a concert or whatever, that has the potential to use that C13 and plug it into the back of a computer power supply, which uses a C14 connector, the mating version connector for it. And so then, of course, because this doesn't use standard lab, neutral, and earth, that can cause problems with the power supply, and kaboom, the end of the computer. So that's the only kind of bad thing if you're using the wired remote here. So obviously, if you're using the wired remote, don't use extension cords with it for that very reason of possible cable mix-up. For the record, the actual fog machine here does use standard live and neutral wiring. As you see, there's a thing on the chassis of the pump here, which then goes to an earth connection on the chassis and, of course, into the cable. So the actual metal box part of the fog machine, that's fine, uses the standard wiring. Again, it's just the interface connector for controlling it that's a little bit on the sketchy side. But again, I've had this fog machine for years, and I used it many times, and nothing's gone kaboom, so I'm not going to be too concerned about it. If something that should be more concerning is if you saw a video by Big Clive, he had a fog machine kind of similar to this, but first of all, made for European, so that means 240 volts. And then instead of an IEC 320 connector on the back, it used a 3-pin XLR audio connector on the back. So that means you have a 240 volt XLR connector on there. And if you have this, have that little cheap fog machine kind of in a concert setting, it'd be very easy to get an XLR cable mixed up with all the other millions of ones that you have running around everywhere. And so, you could accidentally plug a microphone into that, and kaboom, there goes your microphone and possibly your singer, etc. So I'd say compared to the one from Big Clive, this isn't nearly as bad. But again, if you're using the wired controller, don't use an extension cord with it. Now, if you have my wireless controller, simply because it's wireless, you don't have to add an extension onto the back of this. And so then, that's, there's no risk of mix-up there. So yeah, that's how this fog machine works. So I will now talk about kind of the history of my Bluetooth controller and how I got to version 3 here. So here is the version 3 of my wireless controller that I've made. So I'll kind of talk about the history of this project. So version 0 of this was made from a bunch of junk stuff that I had laying around and some wireless relays that you could buy off of eBay. Problem is that I could not get the RF version of this project to ever work properly. The main issue that I had was you had to have one transmitter pinging a signal to the remote to the user remote saying the fog machine was ready, and of course you had to actually have the actual transmitter in the remote to tell to tell the fog machine to go. And the problem is, of course, you have the one transmitter was 433 megahertz and the other is 315 megahertz. Interference, unreliability with environmental interference. It never worked reliably enough. So I ended up just dismantling the whole thing because I knew it wouldn't work. Version 1 came around. So version 1 I made when I learned how to use Easy EDA here and to actually how to make a proper circuit board instead of just shoving a bunch of pre-made parts together. So version 1 was quite a bit different from versions 3 here. So first it used a mechanical relay that I had. So of course that makes noise, and I don't like things making noise when they don't have to. Then that was the really only major difference between version 1 and version 2 here, which I will show. So version 2, open it here. So we'll pull the dismantled circuit board from it. So version 2, main thing that I'll note is that instead of a mechanical relay, it used a first time implemented a solid state relay in this design. So completely silent. And so yeah, that's the only major difference between version 1 and 2. Now we'll talk about V3 here. So we'll just talk about the chassis first of version 1 and 3 and 2 and 3 here. So first major difference is you see on version 3 we have a battery pack, and that's because all subsequent previous versions of this project used line power. The major reason I did that is just because that way I don't have to worry about batteries running low, etc. Made that a little bit easier. But then of course, you have to deal with line voltage, which is kind of dangerous. Second major difference is on version 3, you see there's this big cable gland on the back being used as strain relief for the control cable. Whereas on the bottom of this, you just have a hole coming out the bottom, which is kind of tight to the diameter of this cable. So it just looks a little more professional. You don't have to worry about the cable getting pinched and cut into by the plastic. And of course, there's another hole here, of course, for the line cable, for line power. Then we can open up the version 3 here, and so we see on the inside here, there's the main board, but then 90 degree to that, you also have a board with screw terminals on it. And that's because on version 2 here, any screw terminal connections that were required were directly on the main board. But this made fishing the board out of the version 2 and version 1 as well quite difficult because you had to fish it up, pull the control cable up through the thing, unscrew it, and then you can get the board out the rest of the way. Kind of a hassle for if you needed to do something with the board, whatever. So then what we can see here on version 3, if I can just get my fingers down in there, board pops out very easily. And we can see we just have some male pin headers there. And then get the light just right. You can see some female headers there for the board to plug into. If my camera would focus, that'd be really nice. Okay, but you can see there's some female headers in there for the board to slot into. So that makes servicing this board just a little easier if I ever need to. Then the next major difference, so all previous versions I said were line powered, and this third version is now with just 2 AA batteries. So that means there's this little boost converter circuit on here using this LT1303 chip. So that's different. I didn't have that before. Of course, I had a little AC to DC power supplies inside there. And then the next major change between versions 2 and 3 here is the microcontroller itself. So on version 2 here, I'll bring it over. Version 2 here, you see it has an outline for an Arduino Nano. Whereas with this uses a Pikaxi 08M2. Let me switch over to the other schematic here. So yeah, Pikaxi 08M2. So what these guys are is they are some standard 16-bit PIC micros, but then this company from the UK called Revolution Education puts a custom bootloader on them. And so what that bootloader does 2 things. So it allows just a standard 2-wire serial connection for programming. So you don't have to use some proprietary complicated programmer. And as well, it allows you to program these microcontrollers in a custom version of BASIC. So that also means that the bootloader on here has a little BASIC interpreter running to interpret your code on the fly there, based off how the BASIC language works. And so with that, there aren't too many other changes. Of course, these Pikaxi microcontrollers use a 3.5mm jack for programming. So that's on there. Of course, the Arduino now just had a USB connector on them. But as you see, there's kind of a little bit of a chew up and whatever mess over here, and that's because I got the sleeve and the tip connection mixed up there. So I had to do a little bit of a bodge so that I could actually get the programming to work on this. So if I ever need to reprogram this, say if I want to put some, like a countdown or something in there or a delay, then I can just reprogram this if necessary. So kind of some other things, just generally how these my system works. So the Bluetooth is not handled at all by this microcontroller. It is handled by this SparkFun Blue Smurf Gold, which, as we can see, it just has this little RN41 on here, which, from what I can tell, this product has since gone obsolete between making versions 2 and 3 here. So I can't make another, identical version of this if anybody would ever be interested. So, that's kind of sad, but whatever. Just kind of a one-off project, just trying to build my skills up. Then, how does the whole, controlling the AC side work? Well, that's where this solid-state relay comes in, and then also under here you have your neon bulb and a photoresistor. So how does that all work? So, when the fog machine, when the bimetallic thermostat closes here, opens, because the heater's up to temperature, voltage appears on the common live connection. So that means this neon bulb will turn on. So this neon bulb turns on, and that shines on this light-dependent resistor. So when light shines on a light-dependent resistor, the resistance decreases dramatically, and that means voltage across this fixed resistor here goes up to approximately 5 volts. And so the microcontroller will see that as a logic 1 on its input, and then that sends a notification to the user to say, hey, the fog machine is ready. And then, of course, the user will send an ASCII character 1, which I believe it's a 49 in ASCII, through the to the Bluetooth terminal here. Microcontroller receives that and then turns on the solid state relay here, which then connects the common live to the pump live. So then the pump has a connection to neutral inside the fog machine. So that's how that works. Of course, one kind of thing that I noticed about this is if the thermal switch cools off enough, obviously it will close again and turn the heater back on. But that means it shorts the pump and the output of the solid state relay here. So I don't know how healthy that is for the solid state relay to have its output like bypassed like that. But I mean the wired switch for the wired controller never had really any issues, so I'm not going to worry about it. Again, it's only about 133 milliamps for the pump there because the pump's only 16 watts, so I'm not going to be super concerned about it. Some other things to talk about on my design here is you can see there's this little inverter here. And so what that is because the when the Arduino sends, or not the Arduino, the Pikaxi sends a serial out stream on its dedicated SEER out pin, it sends it as a negative polarity. So that means 0 volts represents a logic 1. So of course the programming cable for this accounts for that when communicating with a computer, but the BlueSmurf requires that you send a true polarity signal where 5 volts represents a logic 1. So to fix that, serial out connects through this little inverter here, which then goes to the RX pin of the BlueSmurf to change the polarity of the signal, and so that way the data isn't all garbled when on my serial terminal program. And of course the little Pikaxi here can just read standard true polarity output from the BlueSmurf here as normal, so that's all fine. And you can see the little inverter on the board here. So just this tiny little black grain of rice there. I did hand solder that. It took a few minutes, but I did do it. As well, with the little converter here. So I think I stated earlier that, again, what it can do is it detects if the battery voltage is down to about 2.2 volts, or that means it's just a low voltage. And so it'll pull the bat signal here low. And so then your microcontroller knows, hey, battery voltage is getting low, so it can send a notification to the user to change the battery. So that's a nice little feature of this that I implemented. And then you can see this lonely little MOSFET down here, which connects to the primary 3-volt rail. So what that is that it acts as reverse voltage protection. So it's much more efficient than having a diode, and of course it's much more safer than having no reverse polarity protection at all. Because say I wired my battery pack backwards, or the batteries got put in backwards, etc. This little MOSFET protects the rest of the stuff from receiving the negative voltage there. You can check out Afro Tech mods for how this actually works in theory. But that's another nice little feature added to this. So yeah, I got nothing else to say about how this actually works, and I will now do a little demonstration of how the fog machine itself. Okay, so now I'm going to do a little demo of my Bluetooth fog machine here. So as you see, I have a little terminal program open on my computer here, and we are going to connect to a little Bluetooth dongle here. Because next thing also about having batteries is you can have it paired up, and then go and connect it to the machine. So you see we got red light flashing in there on the Bluetooth module. And then just go and hit connect here. Alright, so now you can see the Bluetooth module has a green light instead, so that tells us that the computer is definitely connected. We will now put the lid back on this. Carefully, come on. There we go. We will go and hook this up to the fog machine. Just gonna put my laptop down here. Safe-ish spot outside here. Set the laptop down. Oh, fog machine is just sitting over here, on a little tray in the backyard in the middle of winter. Regina here. Just gonna set this down. Oh, it slots onto the back there. Let me just put my phone down for another second. I'll carefully plug this in. Cord in. There we go. We are connected. And now we just have to wait for the fog machine to send us the signal that we're ready. There's snow here. So this will just be a few minutes while we wait for this. So just set back down on my stairs here so we get a clear view of the fog machine. Just sitting a few feet over there. And we're just gonna watch for a message here. So it should just be a few minutes. Yeah, this is actually, I can sit out here and it's actually somewhat tolerable. Unlike the weather that we have been having with minus 40 degrees Celsius out here. And as you can see, look over there, you can see the little light on the back there to tell you the fog machine's going. And just heating up. Oh, there we go. So we got a message. Fog ready. Just when I was off camera there. So, type a 1 into there. And hit send. So there we go. And then type a 0. And stop it. So now we don't have any fog. There. And so we can see there, when we sent a 1, we got the message fog on from the fog machine controller. There we go. We've got a nice cloud, low cloud there, dissipating very slowly in the cold air, and the fog machine's not outputting anything. Now it does that a little bit sometimes, just spurts a little thing. And then when we got a 0 there, fog off. Oh, it gives you a nice little feedback message there. There you go. Now what we'll do is we'll demonstrate what happens when you let the fog run for a long time until the sensor cools off. So we'll go and see it's going, it's making a lot of fog. You see it going off there. And it's really going there. There we go. And see, it cools off and then it gives you the message fog not ready, fog off. Because what happened there was sensor cooled off, so it closed again. And so then that turns off the well, that cuts power to the remote section. And so then the pump can't go. So now we'll just wait until the sensor is hot again, and we'll get a nice fog ready message. Oh, so we're just waiting. Come on, hopefully this heats up pretty quickly here. There we go. You see we got a fog ready message there again. So that means we can go. Now also, if I tried sending a 1 here when, when the fog machine wasn't ready, the request would just be ignored. Go, and we get fog again. And so then we can type a 0 into here. And hit send. There we go. And we got again fog on and fog off. So that's a successful demo of my fog machine there.